Welcome to Season 7, Episode 1 of Solarpunk Presents, in which Ariel and I figure out whether or not biofuels do more harm than good. Before we begin, let me say thank you again to everyone who supports us on Patreon or who has subscribed to our YouTube channel. We really, really appreciate your help. Thank you. Now for the episode.
Hello, everyone. It's season 7.
Time to talk biofuels.
Because green renewable energy is kind of one of Solarpunk's defining features, so of course we're interested.
Only, are biofuels green? Or are their sustainable, renewable credentials little more than lies brought to us by greedy energy companies?
I feel like that's a leading question, Christina. You know my
Would I
stance on
ever?
this. My goodness, the greedy energy companies are lying to us? Oh no, that's never happened before.
It's so shocking. So shocking.
But before we get into it, maybe we should start this discussion by defining what biofuels are. Like, I mean, I feel like I personally know, but I feel like it would be better to have an exact definition so that we're all on the same page talking about the same thing here.
We can do that. In principle, biofuels are fuels that have been made from recently grown biomass. Generally, this means plants that relatively recently took carbon dioxide out of the atmosphere and locked it up in their tissues via photosynthesis. But it can also include agricultural waste of both plant and animal origin. In practice, biofuels are fuels like ethanol, biodiesel, and biogas that have been made from crops, crop waste, and other agricultural waste in digesters of various sorts.
Digesters, eh? That sounds super gross. Uh, Tell me more.
Oh my God, I think that is the first time I have heard you, a Canadian, say a. I'm very excited about this. Um, yeah. Uh, okay, but digesters. The biologist in me would say not gross at all, but admittedly, not all things necessarily smell wonderful.
Mhm.
So, a digester is really just a glorified container of slurry that you're incubating with bacteria under the right conditions to turn the waste material that you have into the fuel that you want. I suppose fungus could also be involved as well. But you have to feed your flora the right stuff and maintain it all at the right temperature and under the right conditions and make sure not too much waste product accumulates, etc., and so forth. So, not entirely related, but not entirely unrelated, one of the local wastewater treatment facilities that we have here. So it's just treating wastewater. It's not producing biofuels. But they had all the flora in their ammonia oxidation digesters wiped out
Oh
because
no.
the local beer brewery like botched a batch.
Oh.
And they phoned up and they're like, hey, we have all this alcohol we need to dump down the drain. Can we do that? And they're like, oh, yeah, you can do that, but please not all at once. Like, just drag it out over a couple of weeks. And of course, they dumped it all in at once, killed all the bacteria in these big tanks where they where they treat wastewater. And so this treatment facility will be offline for about at least 6 months. And they think it'll take them like 2 years to get back to where they were before because they got to establish the right population of digesters and build their biomass up and sort of spin everything back up to speed. So it can be a tricky business. And there can be a
Yeah.
lot of like industrial espionage with these digesters for making biofuels because people can try to like steal cultures from other, it's biology, so it's different. The populations are different and they're not, they can change over time as well because like that's how things work. And so
Yeah, that I mean, vaguely reminiscent of like I took a beer brewery tour and they were like really like this is our proprietary like batch of yeast, like it's a certain type of like really important yeast that we bred by ourselves and nobody else can have this kind of yeast or something like that. And it was very they were very intense about it.
Yeah,
So
so I think when you're making fuels, you really um it's quite big business to have exactly a very efficient, very flora that's very good at producing exactly the right biofuel that you want. And I think there anyone who's writing fiction, there's some interesting books that can be written here
I
about.
was going to say someone should write like a spy thriller novel about like
Or a
it that sort of
solarpunk espionage, like
oh
industrial
yeah,
espionage
yeah.
novel, where you have this crack team of people who go in and try to liberate the the highly efficient plankton
Yeah.
strains or
Or
whatever.
like there are
Anyways,
two different solar punk societies that work a bit differently, and they keep trying to steal each other's recipes for the biofuel. Anyway, whatever. So at the base, sort of those digesters are basically what turns all of the stuff into just fuel that we can use. I was wondering actually when you're talking, I was like, what about wood? Like we talk about a lot about that over here because Canada's been sort of all about the trees since the advent of settler colonialism. We like chopping them down and making them into stuff.
I don't think Canada is the first country in the world to have chopped down a lot of trees,
Oh,
but
yeah, that's
to
true.
use as fuel.
But we're
Um,
still super intense about it. So,
You have a lot more cheese than most of the rest of the world, I think. But you could stretch the definition of a biofuel to include wood and wood pellets and other fuels made up of organic matter that is too young, unaltered, and fresh to qualify as a fossil fuel like coal, oil, or gas. Right? A good chunk of the human race still uses wood for cooking and heating.
yeah, that's true.
But I think what we want to talk about here today are the biofuels produced through the digestion of the products and byproducts of agriculture or the cultivation of algae. And so this means things like bioethanol, or really, they just call it ethanol, biodiesel, and biogas, which is a mixture of methane and carbon dioxide. Also, biomethane and syngas, which is a mixture of carbon monoxide, hydrogen, and other gases, and various algal based biofuels.
Wow. So, if I understand correctly, so basically what makes biofuels so green is the fact that they're like burning up things that just stored carbon dioxide like last year or within the last couple of decades. If we're talking trees, I guess. So like when we burn them, we're not really adding to the overall amount of carbon in the atmosphere because we're just sort of adding back the carbon that had been recently sucked out and maintaining a kind of equilibrium.
It's such a beautiful idea, isn't it? So at least in theory, using biofuels shouldn't increase atmospheric concentrations of carbon dioxide and therefore shouldn't contribute to global warming.
I mean, since we're having this conversation though, I'm betting that it does, right?
Unfortunately, it's just not that simple. And the way people think about biofuels is kind of the way you would think about a perpetual motion machine.
Like what comes out is always perfectly equal to like what goes in.
Right. And like nothing works that way.
Hmm.
So biofuel proponents tend to ignore that it takes energy, land, and resources to grow biofuel crops and then process them into biofuels. So this takes up land that could be natural ecosystems with all their capacity for carbon storage and for serving as habitat for wildlife. You got to be nice to the pollinators, right? Or that land could be used instead to grow food crops for people. Production of biofuels also produces waste that needs to be disposed of, and that can be literally millions of barrels of liquid waste a year from a single facility.
Whoa. So you're telling me that biofuels are just like not carbon neutral, but they're also like environmentally iffy.
They yes, they they are surprisingly environmentally iffy. Yes.
Hmm.
When you're honest about the carbon budgeting, none of the biofuels comes in as carbon neutral, like none of them. Take ethanol, for example, which is often used to lower the amount of fossil fuel in gasoline. Production of ethanol can be so far from carbon neutral. Its use as a fuel can emit 30% more carbon dioxide than strictly fossil gasoline.
Okay, so if I'm understanding what you're saying, then biofuels, like they're not just not carbon neutral, but sometimes they're even worse than fossil fuels.
They can be, apparently.
Okay, so if wait, all right, so if I were you, how would I put it? So, what maybe started out as good intentions and sort of an oversimplified view of how to produce energy without adding to the atmospheric load of CO2, like it's all very nice and neutral. It sort of got turned into a rapidly growing industry that was making like a lot of profit, often with government subsidies, while driving up food prices, accelerating deforestation, and driving more global warming than if we weren't actually using biofuels at all.
Oh man, you you make that sound awful, but yeah, I would agree with that. Um, and I would say that you left out that by subsidizing and investing in biofuels, we're subsidizing and investing in tech that isn't going to help us get to net zero carbon emissions. And so that's stopping us from fully investing in tech and changes to our economies, cultures, and behaviors that would help get us to net zero as soon as possible. So there's that added as well.
Mm. Can we backtrack a bit? So, what's the problem that biofuels are trying to solve? Like, I mean, the obvious is that they want to replace fossil fuels, but like for which sector or like where exactly? Like, I mean, is it mainly transportation? I read somewhere that despite the boom of electric vehicles, right now more than 90% of transportation is still fueled by fossil fuels. That includes not just the obvious candidates like planes, trains, and automobiles, but also oil and natural gas pipelines, since they need pumps to operate.
Yeah, it's kind of weird to think that you have to put energy into. Well, actually, it isn't kind of weird when you think about it. I mean, you sort of think pipelines stuff just flows, right? But no, you do actually have to put a lot of energy into to pump fuel around.
You mean it's not
Um,
just gravity?
well, yeah. I mean, you think, oh, it's going north to south. It should just go, right? No, but it doesn't work
Slide
that way.
way down there.
Um, so as of 2022, which was the most recent year for which I found numbers, the transportation sector globally emits 8 billion tons of carbon dioxide per year, right? So you can also call this 8 gigatons of CO2. This is sometimes abbreviated as 8 GTCO2 per year. So this means transportation makes up nearly 25% of the 34.6 billion tons of carbon dioxide we people emit to the atmosphere every year by burning fossil fuels.
Oh man. So if we're ever going to hit net zero carbon emissions to the atmosphere, like much less by 2050, transportation needs to find ways to make itself carbon neutral ASAP, and not everyone can afford an electric car. So I thought biofuels would help us with that.
There are roadmaps that have been published for how fast the transportation sector needs to achieve carbon neutrality for us as a whole to be carbon neutral by 2050.
Which is just 25 years away by this point, y'all. Like, it's not some hazy future. It's coming at us real fast.
Yeah, and the older you get, the more you realize that 25 years is just like yesterday, or, in this case, tomorrow. It
Mm.
goes faster and faster. So back in 2021, the International Energy Agency released a net zero emissions scenario, so an NZE or NENZ and NEN not or NZE. Do you guys say Z or Z up
We
there
say
in the Great
Z.
White North? You say Z, okay.
Although, I mean, like in a lot of abbreviations, especially when it's like followed by an E, we'll just say Z because it's easier. But
It
Z.
is. NZE is much easier than NZE. Anyways, sorry. Back in 2021, the International Energy Agency released an NZE scenario that said for us, which is by which we mean the whole world, to be carbon neutral by 2050, the transportation sector needs to reduce its consumption of fuel by about 30%. So it's across the board, doesn't matter what kind of fuel it is, and shift down to no more than 10% of this fuel being fossil fuel.
So, what does that mean in practical terms?
Yeah, it's a big shift, right? So it means running 90% of our transportation off of renewable electricity. But other people see a bigger role for biofuels, which would change that number a bit.
Hey, but why only 90% running off of renewable electricity? Oh, wait, hang on. Never mind. I just answered my own question. It's because running on batteries always practical, or like at least not right now or for the foreseeable future.
Right. Unless batteries get smaller and lighter, aviation, heavy farm equipment, and long haul trucking is probably never going to go electric. I mean, maybe long haul trucking, but definitely not aviation and heavy farm equipment.
Hmm. Okay, so they need that truly green hydrogen that we talked about earlier. So in fuel cells, like we talked about that in like a bonus episode, I think, last year.
I think that was last year, but like I said, I'm old and 25 years is like a day. So
Oh my goodness. Okay.
yeah.
Could you put a link in the show description, maybe?
Yeah, we can do that.
Okay. As you were saying, there are people who want biofuels to play a big role in decarbonizing transportation, which, by the way, is a popular phrase that I'm personally getting sick of because it seems like all the Canadian government does is just talk about how we need to decarbonize toot sweet, and they don't actually ever do anything. There's a lot of decarbonizing transportation like jargon that's sort of thrown around, and nothing ever seems to come of it.
Yeah, jargon. That is a whole other episode. And it's not just transportation though, right? It's also in the generation of heat and electricity for homes and industry. Um,
Okay.
yeah.
All right. So, Christina, I want you to shatter the dream of biofuels for me because I'm easily deluded by marketing when it's about a scientific thing that I don't really actually grasp. So, can you tell me a bit more about why burning biofuels adds more carbon dioxide to the atmosphere than the plants and the biofuels removed when they grew? Like, why doesn't the perpetual motion machine work?
Okay, actually, I have a hard time believing that you're easily deluded by marketing with big scientific words, but I'll
Really
shatter your hmm?
I get really excited about things. So
Okay,
I want
well,
to believe
hmm?
that I want to believe. I'm like Mulder.
Okay, well, let me take a sledgehammer to your dreams here because that's me, Christina, destroyer of dreams. But basically, as I've been alluding to, there is more to the equation than just plants taking up CO2 on one end and engines burning biofuels on the other. There's a lot of stuff in between that releases carbon dioxide to the atmosphere, for instance. And there are a lot of other factors to take into consideration. Like, if we let the land we're growing biofuels on grow back into the forests, jungles, swamps, bogs, moors, or etc. that they used to be, these lands would take up and store more carbon than the resulting biofuels would ever save us from emitting. So the numbers that get quoted for how carbon neutral a biofuel is are often wrong because they don't take many of these things into account, either on purpose or, out of ignorance and, yeah, unbridled enthusiasm for the amount of money these people are going to make
Mm,
and save the world at the same time.
right. So you can't just say, like, we grew this many tons of these biofuel crops, and that's a carbon biomass of this many gigatons. And so that's how much carbon dioxide or carbon, really, these biofuels saved us from adding as carbon dioxide to the atmosphere.
Exactly. These best case scenarios, which quote exactly these kinds of numbers, are some seriously sloppy accounting. They ignore all sorts of things, like that not all 100% of all biofuel crops get processed into biofuels.
Hmm.
Some of these biofuel crops are also food crops or animal feed crops. And so some of the crops tallied as biofuel crops actually get sold on as food or feed instead.
Okay.
But the accounting for how much carbon is in the resulting biofuel overlooks this diversion of some of the crop. Likewise, the lazy accounting overlooks that not 100% of the crop that is actually processed in the biofuel digesters becomes biofuel. Some of the carbon remains trapped in the byproducts of the digestion and then, gets and decomposes back to carbon dioxide that goes back to the atmosphere. So then you have all the carbon that gets emitted while growing, harvesting, and processing the biofuels, since producing pesticides and fertilizer and running farm equipment generally relies on burning fossil fuels. So the normal estimates, which overlook all of this stuff, tend to be major overestimates of how carbon neutral a biofuel is.
But are like some biofuels at least better than others in terms of saving us from like adding greenhouse gas to the atmosphere?
Oh, okay. So at this point, cynical me is going to say that here is where they try to blind us with terminology, like
Mm.
they do with their talk about blue hydrogen and green hydrogen and all of those other rainbow colors of hydrogen.
Okay, so all that will be in our hydrogen bonus chat that we will drop a link to in the description because we talk about this color rating system there.
Companies that like to dazzle consumers and investors when talking about biofuels split them into first through fourth generation biofuels.
Okay, so first generation biofuels must be like old school stuff. So like your grandparents' biofuels.
First generation biofuels are fuels like ethanol and biodiesel that have been made from edible crops.
Oh, so like stuff that could otherwise be feeding people directly as a plant or like indirectly as feed fed to cows, chickens, pigs, goats, other livestock that we then eat. So we're eating the plants, but they're digested first by somebody else.
Right. Processed into proteins and stuff. Right. It's one step further away on the food chain. So, first generation bioethanol, for instance, is made from carbohydrate rich crops like maize, or corn or sweet corn, depending on which version of English you grew up with. Or it can be made of wheat, sugar cane, or sugar beets. And these crops are turned into starchy, sugary feedstocks that are fermented by bacteria in enormous anaerobic digesters. And, et voila. Oh, God, my French is so bad. Ethanol. This bioethanol is then used on its own as a fuel, or most often it is added to gasoline.
Okay, so what about first generation biodiesel?
First generation biodiesel is made from oil rich crops like soy, rapeseed, aka canola, and oil palm. These crops are processed through a series of industrial steps into biodiesel. This biodiesel can be used directly in specialized diesel engines, or it can be blended in with petroleum diesel to make mixtures of up to about 5% biodiesel for use in conventional diesel engines.
So we've pretty much all been propelled by these first generation biofuels, right? Like, I mean, they're really popular and there's a huge industry that's materialized to produce them. So think of all that corn in Nebraska or Europe or the canola from the Canadian prairies that gets turned into ethanol that then gets added to gasoline. And side note, I'm just going to tangent a little bit here, but the word canola was literally coined to mean Canadian oil. We're all very proud of it being Canadian innovation and all that. And it's a $1 billion industry and it's one of our major exports. So there's like incentive for the Canadian government, I bet a lot of governments that produce these crops to sort of market these first generation biofuels.
Oh, that's weird. I always think of canola as a cooking oil and is like a nicer word than rapeseed oil.
Oh yeah, it's totally a nicer word. It's just that it doesn't exist independent of politics.
So, total aside here, which I don't know, maybe I mentioned this once before because, at this point we know each other so well, I'm starting to repeat my stories. Um, but a couple of years ago, I remember reading, I don't know, it was probably on what used to be Twitter back in the old days, about a German paint company that was selling paints on the internet. And of course, it's in English for an international market. Now, in Germany is full of canola fields. And
Mhm.
in German, that's called Raps. Oh God, my German is also terrible. Raps.
Okay.
Anyways, and you're Canadian, so you know what color these fields are in spring.
Mhm.
They're this like eye blistering yellow.
Yes.
Right. And it is a very specific yellow. And in German, you would totally understand if someone says Rapsgelb.
Oh, okay. So like the
So,
yellow that canola oil or that canola plants and flowers.
right, right.
Okay.
And so on this paint company then had this paint color, which they translated into English as rape yellow.
Oh,
Yeah, that
that's
didn't go over very well.
no, no. And you have not told me that story, by the way, so don't
Oh,
worry.
woo. Okay. So yeah, it always it and it, major own goal there. They could have totally avoided the social media pile-on that they then
Yeah.
suffered for
Yeah,
that
they
little.
used someone to translate who maybe was also familiar with the culture and not just the language.
Well, and in Germany, I think it's incomprehensible that there are parts of the world that who don't know the color of these canola fields in spring but in large parts of the world they don't grow. So
Yeah.
yeah, so the understanding is not there. But and yeah, anyways, that was just an aside. So yes, as you were saying, we've pretty much all had burned this stuff in our vehicles or ridden on a bus that has burned fuel that has at least been somewhat adulterated or diluted or whatever with these first generation biofuels. And when you do a conventional life cycle analysis, which is this industry standard for figuring out how carbon neutral a biofuel is, these life cycle analyses, which are also known as life cycle assessments, which is pretty much just accounting. You're like, well, we grew this much biofuel crop, and so it took up this much carbon dioxide out of the atmosphere. That's just mass balance. And then the processing of the biofuel probably emitted this much carbon dioxide to the atmosphere. And yeah, okay, there's this much carbon dioxide that's associated with, doing the agriculture itself. And again, you're working from estimates. It's not stuff you're measuring. And those estimates are maybe not as accurate as they could be.
Let me guess, it overlooks the added aspects like deforestation that you mentioned earlier.
Oh, that's a whole other kettle of fish. But mostly these life cycle assessments they just really underestimate how much carbon dioxide the biofuel producing the biofuels, like overall everything associated with the production of them, emits to the atmosphere. So these conventional life cycle analyses make biofuels look good on papers that get shown to politicians who are happy to dole out subsidies to farmers for growing biofuel crops.
Mm. Sadly, the politician who's interested in the truth of the situation is far more rare than the politician who's looking for an excuse to dole out subsidies for his or her lobbyists or constituents. Especially here, since we were kind of founded as a resource colony and extracting, exporting things is kind of what we do.
That's interesting. I've never really thought about Canadian industry before.
Yeah, I mean, our biggest industry is like oil, and we take it out of the ground and then we ship it somewhere else. So,
Oh, okay. So not it's not like ice hockey or maple syrup or I don't know. I don't know what.
no. I mean, maple syrup is a big export. That's also, extracting something and then selling it somewhere else. But at least, like it's, we do that on a much smaller scale.
Well, it's also a renewable resource in as much as if you don't kill the trees, you get more sap out of them every winter. But to get back to biofuels and these first generation biofuels, there was a study that instead of relying on the industry standard life cycle analyses of biofuels, track the flow of carbon through the whole system. So that includes the fossil fuels, the crops, transportation, and biofuels. And they did this for the USA to check on the impact of biofuels, in this case, mainly bioethanol, on carbon emissions there between 2005 and 2013. And when you sort of look at the carbon flowing through this whole system, and what I mean by this is that if you actually go out and compare the extra amount of carbon dioxide that was being taken up out of the atmosphere by growing more and more biofuel crops over this time period, and you compare that to the extra amount of carbon dioxide that was returned to the air during the processing of these biofuels, the production and processing of these biofuels, what you find is that the production and processing of the biofuels added more carbon dioxide back to the atmosphere than the growth of the biofuel crop removed. What you find, or what the study found, was that the carbon dioxide taken up by the growth of the biofuel crops canceled out only 37% of the emissions related to burning the biofuels. And so that doesn't even begin to compensate for greenhouse gases like CO2 released to the atmosphere during the production and processing of that biofuel. In other words, this bioethanol isn't even compensating for the amount of carbon dioxide it directly releases to the atmosphere, much less compensates for any of the carbon dioxide it indirectly releases to the atmosphere. So it's really far from carbon neutral. So first generation bioethanol is so far from carbon neutral. When you use it as a fuel, it turns out it's nearly 30% worse in terms of carbon emissions than running a vehicle purely on fossil fuel.
Ouch.
Yeah, I mean that's I think worse than even cynical Christina would have thought. So
Yeah, that's horrible. Um, and now I bet that you're going to add insult to injury by telling me that this first generation biofuels drive up the food prices because they're based on edible crops.
exactly. And then, because of the increased price of these crops, farmers deforest even more land to grow even more biofuel crops that then release all the carbon that was stored in these soils and ecosystems.
Oh man, it's like a merry-go-round of horribleness. Please tell me that second generation biofuels are better.
So, first, let me tell you that second generation biofuels are produced from leftovers and discards.
So I'm guessing that means like agricultural waste and byproducts like straw and animal waste, like used cooking oils, waste wood.
And also things like woody shrubs grown on wasteland and in some cases even sewage.
So I don't know, that seems good because it doesn't drive up food prices and it doesn't actually like have a land use problem associated with it. It's just kind of using up what's left over from what already was used before.
Unfortunately, second generation biofuels don't turn out to be notably closer to carbon neutral than first generation biofuels.
Oh, why not?
Chemistry.
Oh.
First generation biofuels cherry pick the starchy and oily components of the crops, right? So the energy rich stuff that's also really easy to process into fuel.
Okay.
Second generation biofuels get stuck with the woody, fibrous bits, more or less, full of hard to ferment things like lignin and cellulose.
Oh, so I would imagine that that kind of makes the processing of these second generation biofuel materials like a lot harder and more costly than processing all the like nice, easy first generation stuff.
So cleaning up the feedstocks before they're processed into biofuel takes a lot of water and so it produces a lot of wastewater. It also takes a lot of energy.
Okay, so, and I mean, going back to your beer story, it's wastewater that needs to be disposed of in an environmentally sound manner in places that are rural and therefore not necessarily equipped to deal with large volumes of wastewater.
Exactly again.
So we do a lot of mining, fracking, and oil sands extraction up here. So wastewater and spillage is kind of like a regular thing that companies like to pretend doesn't actually happen. And it usually destroys either like river systems or farmland in the process, and sometimes both.
Oh, wow. I hope that doesn't really happen all the time up there.
I mean, like it's not happening like every minute of every single day, but it does happen more than you'd want it to.
You know, it is hard to contain things. Anyway, so it isn't just that the wastewater itself is bad, although it can be. But if you need to get rid of, say, like 1 million barrels of wastewater from the production of something like, oh, let's say sustainable, so-called sustainable aviation fuel, that's a second generation biofuel, and the only option near you is to inject this wastewater into spent oil wells. You know, that's also not a great option because those oil wells contain petrochemical residues that all that water could flush through the system and out into groundwater reservoirs if you're not careful.
Ugh. That's a way too familiar scenario here in North America.
Another fun fact, if you aren't careful when doing your digestions, and if you're digesting animal waste, such as manure, you can end up cultivating pathogens that are present in the waste. So things like the botulism bacterium. Then, when the slurries that are left over from the production of something like biogas, so that methane that you can produce through these digestions, are spread out as fertilizer on fields, which is what happens to them, you can end up with herds of cows who eat the food that's grown from that field, And actually also farmers who work in contact with the slurries, they can end up infected with the botulism bacterium. It can take up like residence in their intestines, I think it is. And so then they have this chronic botulism intoxication is not quite the right word, but these chronic cases of botulism that are very debilitating, sort of career ending, and just make people's lives a misery. Another fun fact: by implementing and publishing studies designed to yield confusing results and then interpreting them falsely, the biogas industry managed to kill funding for research on this topic here in Europe. I mean, I was really shocked as a scientist when I dove briefly into this literature a couple of years ago. Completely insidious. Completely insidious. Now here's Ariel going back to, yet another drawback of these second generation biofuels.
Also, I bet that leftovers and discards are a limited supply also. They like there's just not that much secondary material to make just second generation biofuels from. So never mind whether or not they're carbon neutral, they couldn't really be a big replacement for fossil fuels.
Yeah, that is a good point. You know, and second generation biofuels are too new for that comprehensive carbon flow analysis, like I talked about, for that had been made for first generation bioethanol. But even the, more softball life cycle analysis doesn't clearly show that second generation biofuels are much of an improvement over fossil fuels. Because you need to use an awful lot of fossil fuel to make the second generation biofuels because it's so hard to process the leftovers and discards into biofuel.
So you mentioned third and fourth generation biofuels. I'm guessing that the picture doesn't really get a whole heck of a lot better, does it?
So third generation biofuels are made from algae and cyanobacteria, which cyanobacteria are a type of phytoplankton,
Mm.
photosynthetic phytoplankton. So meanwhile, fourth generation biofuels are, or rather at this point, more will be than are, made from organisms that will be genetically modified to be better fodder for biofuel production.
For third generation biofuels, couldn't they use those like harmful algae blooms that are like clogging up waterways because of excess fertilizer that runs off like agricultural fields and into rivers and lakes and that kind of thing?
To me, that sounds like it could be a major win-win, right? You could clean up the waterways and get fuel out of it in the process, right? Companies could even grow the algae on waste nutrients in tanks or bioreactors, so you wouldn't even have to like harvest this stuff out of natural waters. You could just stop it from getting there in the first place. And that would convert carbon dioxide into biomass that would then be used to make biofuel instead of letting those nutrients ruin aquatic ecosystems.
Oh wow. I mean, that sounds really positive and solarpunky, and so it probably can't be true. It would make far too much sense. I would say that probably, like it's not so cheap to do that, and biofuel entrepreneurs tend to only see dollars.
But yeah, things aren't often done in a way that makes sense. For instance, because of carbon credits and the carbon market, people want to feed the bioreactors with carbon dioxide captured from industry, right? So the things that are coming out of smokestacks or whatever. But that's not carbon that is captured and stored. That's carbon that is captured and then re-emitted when the biofuels get burned. Right. So it would be better to grow the biofuel algae with carbon dioxide from the air, which is really hard to extract, but algae is good at that. And so are plants. And then take the carbon dioxide captured from industry, which is something we can do because it's really easy. These high concentration point sources are really easy to extract carbon dioxide out of. And then we can take that captured carbon and store it somewhere permanently away from the atmosphere. Does
Hmm.
that make sense? I'm not sure
Yeah.
if that was clear.
Yeah, that was clear. It was just a lot. I was thinking through it. Because and I was sort of hung up on the fact that you talked about like genetically modified organisms. Like I'm not too sure I'm very keen on that. Like messing around with plant genetics tends to just give like big companies like Monsanto more of a monopoly on crops and disempowers farmers.
I suspect it will probably be hard to hold the industry back from going this route. I mean, so people are already trying to genetically modify plants, algae, and cyanobacteria so that they have a higher than natural photosynthetic efficiency.
which means
That means that they can grow faster with less light than unmodified organisms because they've kind of tinkered with the way they capture the light and the way they handle that energy. So that it's a little bit more efficient. Um, People are also tinkering around with bacteria and phytoplankton and all of that, so that they produce a much higher proportion of the compounds that are needed to make biofuels as
hmm,
well.
okay. I bet there are people who would say, like, so what if a more efficient photosynthesizer escapes from the lab and takes over the ocean, spreading its highly photosynthetically effective genes to phytoplankton everywhere? All the extra carbon would start getting removed from the atmosphere.
Yeah, uncontrolled potential total global science fiction disaster.
Like massive sucking of carbon dioxide into the atmosphere and into plankton would send us into a snowball glaciation.
Global snowball glaciation, it would be an extreme scenario. Although I have to admit, I'd rather not find out how implausible, actually.
Okay, okay, well,
Or not implausible, I mean.
like there's a hilarious side note that I'm just gonna go on very quickly here. This is why I'm so excited about it. It's actually the plot of a Canadian science fiction novel that was published in the 70s. It's called The Lord's Pink Ocean, and it's a satire on race relations and religion. Oh, there's no glaciation, and the algae was like bioengineered to like eat plastic, I think.
Okay, I'll have to check that one out.
I mean, it's not that good. But like the whole sort of like principal conceit of the setting is that this algae escaped from a lab from like because of scientists from government.
Well, I mean, it is kind of hard to keep little microscopic things from escaping.
Mm.
Um, in all honesty. The glaciation scenario could happen though. I mean, even lesser perturbations could have seriously disruptive effects on the cycling of carbon throughout the climate system. If you start tinkering with the efficiency of photosynthesis, then yeah. And and the whole carbon system is pretty finely tuned by natural processes to hold Earth's climate within habitable bounds. So I mean, yeah, there are certain things you shouldn't tinker with, and the
Yeah.
efficiency of photosynthesis is just one of them.
Yeah, I don't think that sounds like something you'd want to be messing with for like just a bit of profit for you and your shareholders.
Well, as if that has ever stopped anyone.
I mean, fair. Um, if I don't laugh, I'll cry. This is a lot to think about. Your skepticism of biofuels at this point seems very justified, totally justified, in fact, to me at this point.
I mean, it's a major bummer because it's such a nice idea, right? You just grow things and then you burn them and then they grow again, right? But nothing, of course, is ever that simple. And I think
Right.
it's fair to sum up in 5 words: biofuels do more harm than good.
Well, you've said they're so far from carbon neutral, it's actually better to burn fossil fuels than to put bioethanol or biodiesel in your car or airplane. And you've said that they create terrible volumes of wastewater and that they drive up food prices and that they encourage deforestation and that people are starting to create frankenplankton in order to make better biofuels.
And that's cute. But yeah, I think you got the gist of what I wanted to say about biofuels.
And yet, we're inundated online and off with biofuel propaganda.
Yeah, if you start to look at the internet and you start to read articles or you look at websites about biofuels, then you realize there's all these articles and websites written by people who are pro biofuel for whatever personal or financial reason. And there's some pretty serious propagandizing coming from them and from the websites of the companies producing biofuels. It's really, really shocking, even for a cynic like me. And it's shocking, yeah, but also not shocking to see that over the last several decades, biofuels have gone from being a product of naive, wishful thinking into a really explosively growing industry, uninterested in the fact that its so called sustainable products are nowhere near carbon neutral. These people don't care about the future so long as it involves them making money.
Okay, I'm not saying anything because like I don't really know what to say. I'm kind of at a loss for words. I mean, yet another reason to be on the lookout for greenwashing. I think people hear the bio in biofuel and assume that it means good for the planet and not just like derived from biological material. I like the literal meaning. It's sort of the same bait and switch that's used by fossil fuel companies that are trying to market like so-called quote unquote natural gas.
Right. We talked about that earlier. I mean, 20 years ago, I had scientist colleague friends, like professors of ecology, of marine ecology and stuff like that, who were very excited about their wood pellet heating systems, which is, also falling for this biofuel greenwashing. I think today they would be like, "Oh no, right, that's bad. That does more harm than good." But still, even people who know stuff get fooled by this stuff.
Yeah, well, like, I mean, 20 years ago, I'm sure that there wasn't quite as much knowledge about biofuels as there is now. So, like, I wouldn't, I wouldn't say like they're like the companies that know very well that their gas is not natural and they still say it's natural. Like,
Oh yeah, I mean, there is so much misinformation out there about what is climate friendly and what isn't. I don't know how anyone wades through this without a
yeah,
PhD.
right. Well, we'll stick that link to our discussion about natural gas down in the episode description. Oh, this has a lot of callbacks.
Wasn't that part of our hydrogen discussion? I don't remember now. I
Oh,
think it
maybe it was.
was.
Maybe it's the
I
same
think it
episode.
was.
Oh, shoot.
I have to listen to that again.
Well, I'm glad you burst my bubble about biofuels, Christina.
Yeah, another dream successfully destroyed.
I mean, if I've learned anything from feminist theory, is that some dreams do need to be destroyed. To paraphrase Sarah Ahmed, some joys just have to be killed because they're actually actively harmful and not joyful at all and might actually get in the way of good things.
Oh God, no wonder no one likes feminists. But God, that sounds like me every time my spouse is like watching some dumb Bruce Willis or whatever movie on TV. I'm like, oh God, it's another movie where women don't speak.
Yeah.
He's
Well,
like,
I mean,
"Eh,
because you're a killjoy, right? Sarah Ahmed talks
exactly."
about the feminist killjoy, and feminists kill the joys of the patriarchy, and so the messenger is always seen as the bad news itself, and not just the bearer of the bad news. So, like, you didn't make a world where it sucks that these action movies don't have female like women speaking in them, but like you are somehow seen as the originator of like bad stuff when you're
I'm
just
just the bitchy person.
yeah, exactly. You're just pointing out the bad stuff. You're not the bad stuff itself. Like that bad
Yeah.
stuff is making you feel bad, And so I don't know, you're just sharing your experience with other people.
Uh, yeah. I'll tell him that next time. But
Yeah.
anyways, this would, yeah, kind of actually describe biofuels. It's a dream that needs to be destroyed because it doesn't live up to what it says it is. It doesn't live up to its ideals.
Well, all right then. Consider me educated. And thanks so much for this.
Okay, you're welcome, I guess.
Well, listeners, I think the lesson here, other than the one about the science behind biofuels, is that terms like natural and bio should be interrogated, and in fact, might actually be a tip-off to be suspicious until you talk to someone who actually knows a thing or two about the matter at hand.
There are terms that have actual legal definitions, like organic has like legal definitions, and there's a set of standards, and it's important to have legal standards. And this is
Hmm.
one thing I think we sometimes forget when we're like, anarchism, 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 because I'm like, how do you have legal standards if you don't have a government? Which is a whole other question for maybe like a whole other episode, and I don't actually know the answer to. But that's just my little plug here for without standards, we wouldn't have human civilization. Actually, maybe that would be a good thing. But anyways,
I feel
standards.
like there are anarchists who have standards, but yeah, that's another conversation.
Well, but then how do you make sure everyone? Yeah, okay. So, uh, my other half, he loves to read Der Spiegel, which is one of these kind of slightly left-leaning publications. It's a little bit like the New Yorker, but it's a lot more political.
Hmm.
And he was showing me a picture of I don't know, it was a former racehorse and then it wasn't winning anymore and it got older. And so the people who owned it, because people who own racehorses, they're just investments, right? The racehorses are just investments. And if they can't put them out to stud and they're not winning anymore, then they don't even want to feed them. And so this poor horse, like the picture of it,
Oh,
like a couple years after its career was over, it was like starving. I mean, it looked
wow.
horrible. And I'm like, yeah, but this is why this is why we have laws about how you treat animals, because, or, this is why we have legal standards about why we have environmental regulations and stuff like that. Because if we didn't, then there are people who would just be like, well, that cost me money, and so I'm not going to do it.
Hmm. Yeah. Yeah. I mean, you'd like to think that people would just do the right thing, regardless of whether or not they were being told to.
I stopped thinking that a long time ago.
Hmm. Okay. Well,
Okay. But anyways, so I hope y'all learn stuff from this episode and
yeah.
stay solar punk and fight for standards and regulate
Yeah.
environmental regulations, even if you're an
Hey,
anarchist.
Solarpunk and have standards.
That's a wrap for this episode. Thank you for listening. Thank you for listening to Solarpunk Presents, a podcast hosted and produced by Ariel Kroon and Christina de la Rocha.
The audio for this episode was recorded in part on the traditional territory of the neutral Haudenosaunee and Anishinaabe peoples.
And in Germany. The opening and closing music for this podcast is Water Cooler Gang by Monkey Warhol, available for use under the Creative Commons Attribution 4.0 International License.
Don't forget to support us on Patreon at patreon.com/solarpunkpresents.
Every little bit helps us keep bringing you discussions and interviews.
Until the next episode, keep dreaming.
And stay solar punk.